Hello everyone, in this video I'll be explaining you the problem maximum product of splitted binary tree. So let's understand the question. So they've given the root of a binary tree, split the binary tree into two subtrees, okay, by removing one edge such that the product of the sum of the subtrees is maximized. Okay, so return the maximum product of the sums of the two subtree. Since the answer may be too large, return it modulo 10 power 9 plus 7. So they have said, note that you need to maximize the answer before taking the mod and not after taking the mod. Okay, this point is very important. So I was actually stuck here. So I'll tell you why I was stuck. Okay, so now let's understand the question. We have 1, 2, 3, 4, 5, 6. Okay, let's go to the board. So yeah, let me erase the board first. Stuck in this. So in the question they've given 1, 2, 3, 4, 5, 6, which means 1 is a root, and basically take and then try to do it in a BFS way. This is 3, okay, this is 4, this is 5, and this is 6. Am I doing it right? Let me check. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I think I've written 3 to 10. That's why I've got one extra node. So we have 4, 5, and this is 6. Understood. So we have this tree, and in this they are saying you need to split this tree into two subtrees. How can you split? So in a tree, if you divide, if you erase one of the edge, it will split it into two subtree. Okay, if you try to erase two edges, it will split into, maybe it will split into 2 or 3. Okay, so let's see now. This is obvious. If you remove one edge, the tree will be split into 2. So first thing first, I'll try to remove this edge. If you remove this edge, your tree will look like, okay, and we have 6 here and we have 5 here, and your this is subtree, this is one of the subtree, this is other. As you can see, there is no connection to this. So what is sum of this subtree? It is 4. What is sum of this? It is 11 plus 5 16 plus 1 17. Okay, yeah, it is 17. If you do 17 to 4, it is going to be 68. Now I have done this one. Now let me try to erase this. If I want to erase this, your tree will look like this way. So it's like, as you can clearly see, this node is separate and this tree is entirely connected. So what is the sum? Its sum is 5. Now entire this subtree sum, it is going to be 10 plus 16, so it is going to be 80. Okay, we have done this. Now let's try to remove this. So when you have removed this, so 2, 4, 6 will remain as a one subtree and 1, 3, 6 remains as a other subtree. So what's the sum? It's 11, and product we are doing there. What in question they've said is you need to take the sum of all the nodes in the one subtree and need to product with the sum with the other nodes of the subtree. So it is going to be 10, and here we have is 110. Okay, so we have done these three. We have deleted one by one these three edges and then considered the case. Now let's try to do this one. Now if I want to do this, so it is going to be Okay, the subtree looks this way. So this one is one subtree, this is other. So let's try to find the sum. It is 12 into, if you want to find the sum of this is 9. So 108. Okay, now let's try to remove last one. If I want to remove this last 1 2 3 4 5 case, 1 2 3 4 and the last case. So we have 1 2 3 4 5 and the last one we are removing. So it is as like this. So this is one subtree and its sum is going to be 10 15 into, and this sum is 6, it is going to be 90. So among all sums, which is maximum? As you can see, this is maximum, right? 110. So if you remove this edge, then the subtrees whose sum of the products of the two subtrees will be maximum. So this is asking the question that we need to do. So we can do in multiple ways. We can use BFS also, DFS also, but thing is we'll have to use DFS. Now one of the brute force approach would be um, you need to start from root, and what you'll do is you will say that I want to remove its left subchild. Once you've removed this, now your pointer is here, okay, and the next pointer is here. You are saying this way, okay. So what you will do is from this pointer you need to find the sum. What is the sum we have got? Put in a variable, and from this pointer whatever sum you have got, that you put in another variable, take the product, and you will get the sum. Okay. Now that you have done, okay. So now again it's like you will move to the, let's say, this pointer. So which means you want to make the subtree from this root, okay, which is sum is 4 and entire thing will be other. Now if you want to take the sum from this one, you can do the same way, or let's say you want to remove the you want to make the subtree from this node. So it's like 3 and 6 is one node, and then other nodes are other subtree sum. Okay, similarly you can do the other ways. You can do here also, as I said. So once you have done that, so it's like a what you're doing is you are basically going to each node, okay, that is an O of n, and from that node now you will be finding the sum and the remaining sum, right? So once you have done that, which means you are iterating through the all nodes, so n times you will be iterating. It is kind of a O of n squared solution, and your n is given as 2 from 2 to 10 power 4. So 10 power 4 means 10 power 80. So this solution will give you TLE. So we should not think of in this way. rather rather if you think in a way like, let's say the same approach I'll be thinking, but I'll be thinking in a different way. What I'll do is I will try to make sure from the leaf node, okay, I'll try to make sure from the leaf node this node is a separate subtree and the remaining is a separate subtree, right? Once we have got this sum, the remaining sum whatever we have can be calculated easily, right? You don't need to iterate through this nodes. How? Because once you've calculated the entire subtree sum, so let me call it as total sum. It is going to be sum of these all elements. So it is going to be 11 12 16 18 21. So entire subtrees entire tree sum is 21. So what you are doing is you are moving to the leaf node and you are saying like you are moving to the each node, okay. Now you are saying this is my subtree, okay. So from this node I will remove this edge. It's like that way. So total sum is 21. So this subtree sum is 4 and the remaining subtree sum will be 21 minus 4, okay, and you do the product now, okay. Once you do the product, its value will be 4 into this is 17 68, right? Now you will move back and then you will move to this node, and in this node also you will say I want to delete this edge. When you're deleting this edge, the sum is 5. This is subtree, okay, and the remaining sum will be 21 minus 5. 21 minus 5 is 16. 16 into 5 is 80. Okay. Now when you move to the above, you were actually doing DFS, you went to the leaf node and you started doing these things. Now you have done, you have called left, you have called right, now you are at this. When you are at this node, what does this mean is that you want to remove this edge. If you want to remove this edge, the entire nodes value, whatever you have, that is kind of one subtree, okay. And this sum, how can you calculate? We don't need to go back to all the nodes and find the sum. What you can do is, when you are returning from these nodes, okay, you have calculated the answer for this, and when you are returning, you need to return whatever sum it has, like subtree sum. So it has a sum of 4 and this has a sum of 5. And when you are at this node, parent node, so what you'll do is you'll take left child sum, right child sum, and add its sum. So it's like 4 plus 1, 9 plus 2 is 11. So it's like the entire subtree sum is 11 and the remaining will be 21 minus 11, and which is going to be 110 because this is 10 into 11, okay. You have done this. Now when you are moving back, now you will be returning the entire sum, okay, whatever sum you have, subtree sum, which is 11, you will be returning 11. Now same thing you will do, you will move to the right hand side, then you will move to the left hand side. Left hand side you have nothing, so it will return 0, okay. You have nothing, so it will return 0. Now sorry, my bad, it has left hand side as 6. So it has left hand as 6, and when you call here, so it does not have left child, so it will return 0. When you call this, it does not have right child, it will return 0. And now this at this node, what is the sum? 0 plus 6 plus 0 is 6, okay. So it's like you are deleting this edge, and this edge is the, I mean, from this node we have a subtree, and whose sum is 6, okay. It is like 6, and remaining sum will be 21 minus 6, which is 15. 15 into 6 is 90. Got it? Now you will move back. When you are moving back, you will return the entire sum, subtree sum, so it is 6, okay. Now when you are at this basically node, so from okay, we have moved to left hand side, now we will move to right hand side. Right hand side you have nothing, so it will return 0, okay. And this 6 was returned by left child. Now on this node, your subtree sum is 6 plus 3 plus 0, which is 9, okay. It is 9. Now you will be doing 21 minus 9, and this will give you 12. 12 into 9 is 108, okay. So now you will move back to the root node. When you are root node, what you will have is from here we will be returning actually 9, and you have 11 plus 1 12 plus 9. 12 plus 9 is 21, okay. So again, same thing you will be doing with the root. It's like you have taken the entire tree, but this case is like you will feel entire tree we are taking, but we don't have other as a subtree. But this case will not be holding good, right? Because when you're taking entire tree, its sum is 21, and the other sum is going to be 21 minus 21, which is 0. So the product will be 0, right? If product is 0, so it is not okay. You have already got the maximum. You will be keeping one as answer variable, and wherever you find the answer as maximum, so that will be your maximum, okay. I think you have understood. What we need to do is we need to first find the total sum. We'll move to the end, okay. When we don't have any child, that will return as 0, okay. And here also we don't have child, it will return as 0. So left child plus root node and plus right child, whatever value we have, that will hold as a subtree, okay. And the total sum minus this subtree sum is going to be the two splitted subarray sum, and we need to make the product. So I think approach is clear. Let's try to code it up. So let me try to erase this. Now first thing first, we need to find the total sum. Let me call a function find total sum. Okay, I'll pass the root. Let's write one private function. It will return int, or you can say long, because the reason why I'm making long, I'll tell you. See, we have 10 power 4 as value of each node can be at max 10 power 4, and we have 5 into 10 power 4 nodes, such nodes. So the sum is going to be 10 power 8. Okay, it may be 10 power 8 and 10 power 8 is the sum of the entire subtree. So let's consider a case wherein half sum, which is 10 power 8 by 2, is left subtree, and then one subtree sum, and other will be the 10 power 8 by 2. So if you multiply that, because we are taking the product, right? So if you multiply that 10 power 8 into 10 power 8, it is going to be 10 power 16. So your integer will not hold. Okay, that's why I'm making sure I'm taking total sum as long. Like total sum will be good enough to hold an integer, uh, just to make sure it is not overflowing when I'm doing a product. So that's why. Okay, and ll I'll define here. So I've defined long, and I need to find total sum. I'm passing tree node. My base condition will be if root is equal to null pointer. If root is null, then there is no value of the root, so we need to return 0. Else what we can do is we can return find total sum. Basically we need to call the left child plus whatever root value we have, plus we need to find the right. It's like we are at the root. Okay, so we need to go to the left child, then we need to go to the left child, then we are going to the left child. We don't have, we'll return 0, and whatever root value is there we are adding, and then we are calling the right child. When you calling the right child, it will also return 0. So sum is 4, now it will return back. Okay, left sum is 4, now current value is 6, 2, which is 6. Now it will call right side. From right side you will get 5, so you will add, it is going to be 11, it will return back. So yeah, this is a typical um, DFS. Okay, or you can say in order, yeah, in order traversal. So we have find the total sum. Now thing is we have to find the maximum product. Let's take long as answer, initially to be 0. I'll call a function find max sum product. Sums product, there are two sums, or you can say find max sub tree. Okay, let's call a function name find sums product. This only, basically it will return the answer. So we need to pass the root, and we will pass total sum, and then we'll pass answer, and when we come out of the loop we need to return answer. Okay, I'll tell you how to deal with the modulus. Now the return type of this find max sum will be long. Basically we'll be returning the sum of the subtree. Okay, sum of the left subtree and right subtree tree. I'm sending the root, and I'll send the total sum. I'll send total sum by reference, because total sum will remain constant. Okay, so it's like we are not changing, so that's why I'm passing by reference. So it's like memory optimization. Now I'll take my answer as long, and I'll pass it by reference, because anytime this answer is changed, it should remain changed only. Okay, So now I'll find here if my root of if root is null pointer, which means uh, it's like we are at 4, we don't have any left child, so we're returning 0. Okay, that way I'll take sum 1, or I can take left child sum. Left child sum will be find max sum product. I'll call left hand side. Okay, from the root I'm calling left hand side, and my total sum will go as it is and my answer will go as it is. Once I find the left child sum, now I need to find the right child sum. Right child sum, it is going to be find max sum product. Basically I'm doing a DFS. Okay, right total sum answer. Once we have left child sum, right child sum, my subtree sum is going to be uh, subtree sum is going to be left child sum plus whatever root value we have plus right child sum. Okay, this is my subtree sum. Now your answer has to be max of answer comma, you have subtree sum product with total sum minus subtree sum. This thing you got right. Like we have it's like we are at 4, so we have got one subtree, and the remaining sum will be total sum minus this sum. Okay, like remaining other subtree sum it is, and we have answer, and we need to return this return the subtree sum, because our answer is in answer variable. And from here what you need to return, you need to return the subtree sum, like whatever you have all values we need to return. If you are at 1 and then you are calling 2, so 2 will return the entire sum of the nodes. Okay, and before returning answer, now the thing they have said is you need to maximize the sum before taking the mod. So here at this point it may my answer may go it may surpass the integer range, but I'll not be making mod here because they've said in the question you need to maximize the answer before taking the mod. So before taking mod I'm maximizing the answer. Once I found the maximum answer, now and not after taking it. Okay, so they're saying we need to return our answer may be too large, we need to return 10 power 9 modulo 7. Okay, 10 power 9 plus 7 modulo. Okay, we need to return. So we have got a maximum answer, so it may be larger than answer may be very very big, so we need to return as mod. Let me define what is mod. Okay, so 10 power 9 plus 7. Let's try to run it. Hope we don't have syntactic errors. Find maximum sums product. I think here we have issue. Let me copy paste the same thing everywhere. I had put sums product. Okay, yeah. So it is running fine. Let's try to submit it. So yeah, it got accepted and beats 100% of the user. And for me, where it was getting wrong is that I was actually doing mod at this position only. Like whatever sum I found, this was actually different method. Okay, this was an overflow case, but yeah, for this case I think I've removed now. Yeah, I'll show you like what I was doing actually. So whenever I was getting answer, I was doing mod here. Okay, like whatever answer is there, so I was doing mod with that. So this code, if you try to run it, the third case was failing. Okay, this case was failing. So in the question they had said like you need to take maximum answer, and then when you are returning at that time you need to mod. So yeah. So the solution beats 100% of the user, and if you try to analyze the time complexity, total sum we are finding in O of n, because we are moving to all the nodes of the uh, tree. If you take the n as total nodes of the tree, this is O of n, and the maximum sums product function is taking O of n. Again we are doing a DFS. So time complexity is linear, and then space complexity, there is nothing like we are using just extra as an auxiliary stack space. So in the worst case it may be O of n, but in general it will be log of n, height of the tree. Okay, so yeah, thank you guys for watching the video.